Hi, everybody. We have a fun, juicy topic today. It relates to the mitochondria. I'm excited about it. Just before I jump into the meat of the video, if you wouldn't mind taking a quick second to like or share or subscribe or post a quick comment on the video, I'd really appreciate it. So thanks in advance for taking a second to do that. So I'm going to read out the question here and just jump right into it. So it says, could we talk mitochondria and exercise, please? I suspect my mitochondria could be dysfunctional. When I exercise, I get excessive muscle soreness right away, worse the next day. Additional to this, I feel mentally stressed and overwhelmed. No endorphins for me. I think puzzled face or maybe sad face, hard for me to see from back here, working on my vision retraining. I would like to understand how exercise impacts mitochondria short and long term. Why is mood affected? What are the short and long term strategies that counteract muscle soreness? How can I tighter exercise to avoid crashes when energy is fluctuating? One day okay to run 10 kilometers, next day sore after 1 kilometer. And finally, how long does it take for mitochondria to snap out of dysfunction? So a lot of questions in there, but yeah, great questions. So as per usual, nothing I say should be construed as medical advice. This is for informational purposes only. If you need medical advice, please talk to your healthcare provider to get that advice. So kind of talking about how does exercise impact mitochondria short and long term? I mean, in the grand scheme of things, to answer the question really thoroughly, exercise, generally speaking, is really good for our mitochondria, especially when we do resistance training to build bigger muscles. Bigger muscles need more mitochondria, so there's going to be more mitochondrial biogenesis, i.e. synthesis of new mitochondria when the muscles are being built up. And then also when we're exercising, depending on how we couple that with our food intake and this and that, it can ultimately contribute to some pruning of our mitochondria, so helping to get rid of, older, kind of decrepit, mitochondria that are past their prime, and stimulating the synthesis of new ones. So, where every study that's ever been done on exercise basically shows that it's good for us, and it's all just something we intuitively know. It's in part because it's so good for our mitochondria, and it's all about the mitochondria. Now, in folks who are dealing with underlying health issues, so folks who are suffering from some type of complex chronic illness, whether it's chronic fatigue syndrome or fibromyalgia or mold toxicity or persistent borreliosis or what have you, basically the mitochondria are already beleaguered by those toxins, toxicants, infections, etc. And so the mitochondria are already struggling to make enough energy just to run the body in the first place. They're folks who have these issues are feeling tired, they're feeling kind of run down, they're having a hard time with their activities of daily living. But when they go and exercise, so say they go and run for 10K and a person feels better from that, well, if the mitochondria are depleted, the cells are depleted, but they're not depleted to the point of no return, then that extra stimulation from the exercise can make a person feel good, or they can tolerate it just fine, because there's enough energy reserves and there's enough net benefit from kind of that sort of energy expenditure stimulus from the exercise, where the body's like, okay, we can handle this, we're going to regroup, and we're going to come back and bounce back from this. So there's enough energy reserves to deal with that. But trying to do that a couple of days in a row, or doing another 10K run or a 1K run in this case, too soon afterwards, before the cells have had a chance to recover, then that can make a person feel really awful, because the energy just hasn't built back up again. And then some folks, say like, what are you talking about, a 10K run? Like, I have, complex chronic illness and I can't even go for like a 1K walk. Like, what are you talking about, a 10K run? So it's all relative, but when we exert ourselves, we are spending energy. And if we don't overspend our energy and our cells have the capacity to bounce back, we can feel good from that exercise. But if we overspend the energy and the cells can't bounce back, then that's when we're going to really feel unwell. And so kind of the link between mitochondrial function and muscle soreness, well, at the end of the day, we need adequate mitochondrial function in order to replenish our stores of things like creatinine. We need adequate mitochondrial function to replenish our stores of ribose. We need adequate mitochondrial function in order to actually flush out the lactate from our muscles. When we're doing exercise and the muscles start to get sore and tired and fatigued, well, it's that lactic acid building up. The muscles don't have enough oxygen to make enough ATP. The lactic acid builds up as a backup method of energy production. and then when that builds up, the muscles feel really sore. So I've had a number of patients over the years where they have a lot of chronic muscle soreness. The muscles aren't necessarily tight or anything like that, they're just chronically sore, and we get their mitochondria doing better, and that soreness gets better, presumably because the muscle cells actually have the energy to flush out that lactate. Questioning why mood is affected, probably in large part, well, it can be, sometimes like, mood gets affected because like, I ran for 10 kilometers yesterday and can't even run 1 kilometer today, and that's kind of depressing, especially if one's used to a pre-existing better state of physical health. But it could also be because we need energy to synthesize our neurotransmitters, and if the mitochondria if we've overspent our mitochondrial reserves with exercise, then we might not have enough left over to regulate our neurotransmitters properly. Short and long-term strategies to counteract muscle soreness. I mean, at the end of the day, it's really about supporting the mitochondria, treating the root cause factors. There might be a few little things. I'll have to probably post another video because I'm going over time here. And okay, you know what? There's some follow-up questions here that I think I'm going to just have to save for a part 2. So thus endeth part 1 of the video. I'll answer the rest of the questions in part 2. Thank you for the question. Very interesting topic. If anybody has any questions about this topic or anything else, just post in the comment section below, and I'll do my best to answer as soon as I can.